record. Okay, so I've already drawn the product here. So for those of you that are looking on YouTube, the product is drawn at the bottom. And you'll notice that the only thing I've done is I've added an OH group to carbon number 4. And then obviously the hydrogen is added to carbon number 5, but you don't see it in the skeletal formula because it's implied. So if you really want to think about it, you can quickly do an analysis and say there were 2 hydrogens on carbon number 5 to begin with, and there's 3 hydrogens on carbon number 5 in the product over there. Also, the hydrogen didn't disappear. It got added to carbon number 5. And then we say that we say that the OH is added to carbon number 4 as the major product because it has fewer hydrogens. So there's only 1 hydrogen there in the background on that carbon. And then when we see the mechanism later, that's a whole different topic on its own. You'll see why in the mechanism that's the case. Cool. Then what we do is we take this product and we react it with KCN and ethanol. And that's just a functional group conversion. Let's call it a reagent that you have to be aware of. So when you see KCN and ethanol, you have to know that it's going to do something to some part of the molecule. Well, and what you've got to really do is you've got to identify the fact that it's only going to modify the halogen or alkane. So it's going to do absolutely nothing to the OH group on the right-hand side. Also, the product that you end up with here is just... you end up with exactly the same thing. So I can copy and paste it over here. So copy this and then just paste it at the bottom. And then the only thing that you do is you take off the fluorine and you add the nitrile group in its place. So you're going to have to see, I'm going to draw it backwards, but it's just going to be this, and I'll draw it as the C triple bond N so that you can see it over there. And that's the conversion that takes place. So that's your final product. Cool. Any questions about that? Just quickly seeing. No, we're good with the questions and stuff like that. Okay, so I'll end the lesson there. But what I want to quickly do is I want to. Stefan asked this question in class the other day, and I don't know if he meant it the way that he asked it. It was actually in physics, but I'll explain what he said. He asked me, how can I actively study? And I don't know if you meant it in the way that I meant it, but I think what you meant by active study is the way that I understood it. So passive study is you can copy, paste, repeat. And what I mean by that is you can literally go read the notes times 1,000 and just constantly revise and revise and revise. But that's passive studying because all you're doing is you're just reading the notes over and over and over again. But a better approach would be to do an active study. So active would mean play with the topic, also play with the topic, make questions for yourself. You could even Google molecules. You can start on Google and you can start by Googling molecules and you can see how can I convert certain molecules. So I'll give you an example. If I go on the internet, let's have a look at I don't know, paracetamol is a drug that I'm using at the moment. Paracetamol, it's just Panado. So if you have a look at paracetamol, and then if you Google the structure, there we go. So there's paracetamol structure. And you can have a look at that and you can see, is there anything that I can do to modify that based on what I already know? And the answer is probably no, because there's no double bonds. Well, there's the benzene ring, which we don't have to talk about. There's the OH group. There's the amide group. There's the ketone. But there's nothing particularly interesting over there. So you can try a different one. I can't think of one now. Let's think. Acetic acid is vitamin C. Acetic acid. You can Google that. That's vinegar. That's not acetic. That's not with. I'm thinking of ascorbic acid. Ascorbic acid. Oh, yeah, have a look at that. There's a couple of OHs there. Is there anything interesting we can do with OHs yet? Not particularly. There's a double bond there. So if I just download this image and save it quickly, then I'll show you. Hang on, go back. Sorry, I must just download the image. Add photos. Go to the photos. Open that. Cool. So it's a very unfamiliar structure, but you can recognize this here if you see this here is a double bond. So it looks a bit funny because it's got a whole bunch of other complicated stuff, but that there is just a good old-fashioned double bond. And then you can ask yourself, can I add anything to that double bond? Can I add another chlorine? Can I add another bromine? Can I add another whatever? And in this case, you probably can. You can probably add HBr, or you can add just good old-fashioned bromine. You can add water to make another one, to make a double OH or whatever. So you can play around with that. But that's what I think. I don't know if that's what you meant, Stefan, but that's what's meant by active studying. So if you look at the difference, active studying means that you're not just trying to read the notes 1,000 times and try to memorize everything. Active studying means that you sort of play around with it, you make your own questions, and you do a little bit of research and, I don't know, see what you can find out on your own. So Stefan, is that what you meant? I don't know.
Yeah, just like something where you can sit down and do something like 10 minutes a day.
Correct, exactly, precisely. This is like a 10-minute a day exercise, precisely. So instead of reading your notes 1,000 times in 10 minutes, so you have that option. You can do that for 10 minutes, or you can do all of this for 10 minutes, and you can play around with it. And it's far more beneficial to do the active studying because this is basically what the questions are going to be look like. It's going to be a completely novel situation that you've never seen before. It's going to look horrible and complicated, but all you've got to realize is that there's simple relationships between functional groups and how we can convert them. Cool. Any questions?
But so what's cool about physics is that you can think about physics like everywhere you are. Like I remember when we were doing relative speed of approach,
correct.
We were driving, I was driving, and I remember thinking, okay, there's a car in front of me, and I don't seem to be getting any closer. So that kind of means that we're traveling at the same speed. So our relative speed of approach should be about 0.
Correct. I agree with you 100%. It's far more approachable. That's why I love teaching physics, is because you can relate it to the real world. But I'll tell you how you can relate this to the real world is that if you go to your like your drug, your medicines cabinet, so go find out where your parents keep the medicines in the house. What you can do is you can read the active ingredients on the medicines. So at the moment, I'm taking Corenza C, because I'm developing slight cold and flu symptoms. Sorry, that'll come up just now. I'm taking a vitamin C supplement, and then I'm taking ACC20, which is for congestion in the chest or whatever. And then what you can do is you can basically just look up the active ingredients, and then you can have a look at the functional groups and stuff. And then you can ask the second question, is there anything that I can do with my knowledge to change these functional groups? So could I modify this molecule if I wanted to? Let me put it this way, you could do the chemistry at home. This is what Niall Red does, the channel Niall Red. He literally takes stuff that you can buy at a hardware store, that you can buy at a chemist, that you can buy at a pharmacy, and he converts things. He does chemistry at home based on just simple conversions. So if you know the conversions and if you know the functional groups, you could actually do the chemistry at home if you wanted to, and you could make brand new molecules. I'm not saying you should because it's going to be difficult, but it's a possibility. Cool. So that's just a good idea to keep you busy. So a good 10 minutes a day thing would just be play with these things and see what you can come up with. But I agree with you, Kamoz. Physics is far more relatable, far more easy to comprehend in terms of the real world. Cool. I'll see you guys tomorrow. Be good.
Bye, sir.
Bye, guys.
Cheers.
Thanks, guys. Ciao.
Stay healthy.
Thank you, guys. Bye.